Okay, we were in the middle of number 12. We had found our angle, we found our expression for Fn when there was friction, and we were about to do some of the forces in the x direction. And in the x direction with friction, there are two forces, Fnx plus FFRx, and they're going to be equal to mv squared over r. Fnx is Fn. Look at the triangle, it's opposite, so sine theta, because the angle's here, plus friction, which is mu Fn, and in the x direction, it's here, it's the adjacent side, so cos theta is equal to mv squared over r. And then remember, before you plug in your sub in for Fn, factor it out. So it becomes sine theta plus mu cos theta is equal to mv squared over r. And now sub in what we found for Fn down here. So mg over cos theta minus mu sine theta. And then that gets multiplied by sine theta plus mu cos theta. And that's going to be equal to mv squared over r. The m's cancel, bring the r up, bring the bottom bracket up, and so you'll have gr brackets sine theta plus mu cos theta is equal to v squared cos theta minus mu sine theta. Multiply through the brackets, so gr sine theta plus mu gr cos theta is equal to v squared cos theta minus mu v squared sine theta. Bring your mu's to the left-hand side and your non-mu's to the right-hand side. So mu gr cos theta plus mu v squared sine theta will equal v squared cos theta minus gr sine theta. Factor out your mu, gr cos theta plus v squared sine theta. And then this side doesn't change. And now divide both sides by the bracket. I'm just going to do it over here, so it'll be mu is equal to v squared cos theta minus gr sine theta over gr cos theta plus v squared sine theta. And now fill in your numbers. V for the second part was 30, so 30 meters per second squared, cos of 12.415 minus 9.81 meters per second squared times the 175.05 meters sine of 12.415 divided by 9.81 meters per second squared. What was the radius? 175.07 cos of 12.415 plus 30 meters per second squared sine of 12.415. And if you can punch this into your calculator correctly, you should get a coefficient of 0.2886. All right, that was number 12. Number 13, a curve of radius 80 meters is perfectly banked for 64.8 kilometers per hour. What must the coefficient be? It is identical to what we just did, the identical steps. So the first part, r is 80 meters, and the speed 1 is 64.8 kilometers per hour. And it wants to know speed 2 is 90, which is 25 meters per second. This one's 18. So first step, find the angle. Hopefully you're okay to get here. You find the angle without friction. So we're just going to speed up a little and we're going to go to tan theta is equal to v squared over gr. If we were doing a test, I would make you show me how you get to this point just once. I wouldn't make you do it in every question. Okay, so since we've showed it just once, I'm not going to do it in every question. So 18 meters per second squared over 9.81 meters per second squared times 80 meters. And you take the inverse sine of both sides, and you should get a theta of 22.433 degrees. Okay, and so now we're going to do exactly what we did here. Everything is going to be exactly the same. And again, I could go through the steps, but they're identical. So to speed up for part A, you would end up with v squared cos theta minus gr sine theta over gr cos theta plus v squared sine theta. Now you might say on a test, could we do that? I'd never give you two identical on the test, right? So you could if I did, but I wouldn't. So therefore, and we can't have tests now. So okay, so cos of 22.433 minus 9.81 meters per second squared, 80 meters, sine of 22.433, and then we're going to divide that by 9.81 meters per second squared, 80 meters, cos of 22.433 plus 25 meters per second squared times sine of 22.433. And if you could punch this into your calculator correctly, oh, I did the wrong answer here. This one is the one that's 0.2886. Sorry, I was looking at the wrong spot on my already solved sheets. This one is really, shoot. How many times did you have to type that in your calculator? Or did you realize I screwed up? I hope you did. 0.27246. 0.27246. My apologies. Is equal to mu. Sorry. The danger of doing it beforehand and then not looking at the sheet clearly. Did I screw up the angle too? No, it was okay. All right. B is a little tiny bit different because B asks what speed can you go around. So we still have our angle. You're still going to do the sum of the forces in the y, just like you did before. And you're going to end up with just like what we had before up here. Fn is equal to mg cos theta minus mu sine theta. And you are going to sub that in. So when we go to sum of the forces in the x is equal to mv squared over r. And so it will be Fnx, so Fn sine theta minus mu Fn cos theta, just like we had before. And you're going to factor out the Fn, sine theta minus mu cos theta. And then you're going to fill in for the Fn, just like we did before. So it'll be mg brackets sine theta minus mu cos theta divided by cos theta, oh, this is plus, minus mu sine theta equals mv squared over r. Now, here's where it changes. Your m's still cross out, but this time you're looking for v. So just multiply by r. So you'll have v squared is equal to gr brackets sine theta plus mu cos theta. And on the bottom, cos theta minus mu sine theta. So much easier, don't have to, not as difficult rearranging. 9.81 meters per second squared. The r was 80 meters. Sine of, what was it, 22.433 plus the mu, which in the question was given to us to be 0.18, cos of 22.433 divide it by cos